Hello students, welcome again to our year 10 chemistry lessons. My name is Mr. Situma. Now, our topic of discussion today, we are still looking at the calculations. We did look at the relative atomic mass, molecular masses. We discussed in our last lesson the Avogadro's constant. And today, we're going to be focusing on the determination of the empirical formula and the molecular formula. Finding out the empirical formula and the molecular formula of different compounds. If you still recall, under the Avogadro's constant, we were trying to look at the number of particles which are present in a particular atom of a given element. And we discovered that the different masses of the different atoms of the elements contain the same number of particles, which is normally an average value equivalent to the Avogadro's constant, which is 6.023 times 10 raised to the power 23. That is exactly what is contained in every single atom of a given element, despite the differences in the masses. We gave examples, 40 grams of calcium and 12 grams of carbon contain the same number of particles. They contain the Avogadro's constant, the Avogadro's number of particles, that is 6.023 times 10 raised to the power 23. Now, those are so many particles. But now, as we look at that, now that we have identified the atomic masses and the molecular masses, and have also identified the number of particles in those particular areas, we now want to advance this and look at the empirical formula and the molecular formula, determination of the empirical formula and the molecular formula. Therefore, our objective today for our lesson will be to carry out the calculations that will lead into the formation of what we call the empirical formulae and the molecular formulae of the different compounds. We should be able to carry out the calculations which will end up giving us what we call the empirical formula and the molecular formula of a particular compound. But before we look at the calculations themselves, we need to look at the definitions of each of the two terms, that is the empirical formula and the molecular formula. To start with, the empirical formula of a compound is normally defined as the simplest all-number ratio in which the atoms of the different elements are combined, resulting into formation of a compound. The simplest all-number ratio. That means that the atoms combining must bear simple all-number ratios, one to the other. That is, one atom to the next atom. There must be a simple all-number ratio between the different atoms. And when these ones combine together, they are determined within a specific compound. That is what we call the empirical formula. Now, what is simply this one means is that for example, in an ionic compound, if you have, let's say, sodium hydroxide, in the sodium hydroxide as a compound, we have an atom of sodium, that is one atom of sodium, we have one atom of oxygen, and we have one atom of hydrogen. That is, we have this, one atom of sodium, we have one atom of oxygen, and we have one atom of hydrogen. So the ratio is 1:1:1. That is the simplest ratio which can be identified on the sodium hydroxide. So each of these atoms that form sodium hydroxide as a compound are related to each other with a simple all-number ratio. Now, this particular empirical formulae can be determined by using the masses of each atom. That is, we can be able to use the masses of each atom that form the compound, or sometimes, instead of giving us the masses, they give us the percentages. The proportions represented by the percentages of each particular atom inside the compound. Now remember that when we have a compound, let's say copper to sulfate. Copper to sulfate has copper atom, we have sulfur atom, and we have oxygen atom. But the formula of copper to sulfate is CuSO4. CuSO4. So it means in this compound we have one atom of copper, one atom of sulfur, and 4 atoms of oxygen. So the ratio represented in the copper to sulfate is 1:1:4. But then we can also have this in terms of the percentages. That means we can be given the percentage of copper, percentage of sulfur, and the percentage of one atom of oxygen. So that now, from the percentages, we can be able to work out the formula of this particular compound. So we can either work this one out from the masses, if we have been given the masses in grams. We can also work this one out from the percentages, if we have been given the percentages of the different atoms. Now, we can't talk about calculations. Calculations are done. Therefore, we have to look at some of the examples that can bring out what we call the empirical formula of a given compound. We have an example here. An oxide of silicon contains 47% by mass of silicon. Now, when you look at that particular statement or question, there is no more information provided. But if we are talking about an oxide is formed when an element reacts with oxygen. So in this case, since it is an oxide of silicon, then we expect this silicon must have reacted with oxygen to form the oxide. So from 100%, the remaining percentage will be the percent for oxygen, which was used in the reaction. So we have 47% of the silicon, and then we have 53% of oxygen. So they want us to determine the empirical formula of the oxide. Now, let's do the calculations together. We arrange a small table. We look at, first of all, the symbols of silicon. The symbol of silicon is S, capital S, small I. And then the symbol of oxygen is capital O. And then you write down the atomic masses, the relative atomic masses given to you. If you look at the bottom of that particular question, you will see the atomic mass of silicon as 28, the atomic mass of oxygen as 16. That means you will have now, those are the ones you're going to be using. Those particular atomic masses are normally given to you in the questions. You don't have to memorize them. They will always give you in the course of the calculations. So the percentage of silicon is 47%, and then oxygen is 53%. And the R and M, relative atomic mass of silicon, is 28, oxygen is 16. Now, those are the first two stages. The third stage is now we determine the number of moles. The ratio of the mass of the atom compared to the percentage. Ratio of the mass compared to the percentage. That means the moles will be 28 divided by 7. Here it will be 16 divided by 53. Then we can carry out that calculation very quickly. so that we get the actual values. So our 28, I hope you are carrying out this with me, divided by 47. What do you get as your answer? Mine, I'm getting 0.5957. It's a very big value. So we will round off this to the nearest two significant figures. This will be 0.60. Then we have 16 divided by 53. This gives us 16 divided by 53. We get 0.30. 0.30. So we now divide by the smallest. This will be divided by smallest, 0.60 divided by 0.3, 0.3 divided by 0.3. So when you follow up that calculation up to the end, you'll be able to get some values down there. For example, you'll get 1 and 2. The 1 obtained will be for silicon, 1 atom of silicon, and the 2 will be the 2 atoms of oxygen. So that finally the compound will be silicon, 1 is not normally written, and then oxygen is 2. Si or 2. Let's look at the other calculations in our second part of our discussion in this series.